Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we are given a sketch below is the graph of f of x is equals to k to the exponent of x, where k is greater than 0. Then we are told the point 4:16 lies on f, right? Then as we can see here, this is the graph of f, the exponential graph. Then 5.1 says determine the value of k. So now all we have to do for 5.1 is to write the equation f of x is equals to k to the exponent of x. And then if we can check here, we are given the coordinates here. Note that every time we want to calculate the base here, we use the given coordinates in the graph, right? But then we don't use the coordinates in the y-intercept. Okay, so here we have 16. Then this is k to the exponent of 4. Now, since we are dealing with exponential graph, we can write this 16 in terms of exponents so that it has the exponent 4. So we can write it as 2 to the exponent of 4. And then this is k to the exponent of 4. Now, this is k is equals to 2. And just like that, you have your solution for k. Now, okay, 5.2 says graph G is obtained by reflecting graph F about the line y is equals to x. Determine the equation of G in the form y is equals to blah, blah, blah. So, okay, basically what this means, if they say the graph of G is obtained by reflecting the graph of f about the line y is equals to x, this is another way for the examiner to say they want you to calculate or determine the equation of the inverse, because when you reflect a graph along the line y is equals to x, you are simply making an inverse out of it. So what you're gonna do, we know that the inverse of an exponential graph is the logarithmic graph. So all we're gonna do is say y is equals to 2 to the exponent of x, since now we have the value of k. So this is our exponential equation. But then how do we change it to a logarithmic equation? We just say let y be equals to x, since we are reflecting it about the line y is equals to x. So where there's y, I'm going to put x, and then where there's x, I'm going to put y. Now I need to make y the subject of the formula. Now the log rule I'm going to use is this one. I'm just going to make y the subject of the formula, then go log base 2 and then x. Just like that, we have the equation for g. So we can write it as g of x is equals to log base 2x. And just like that, you have your 2 marks. Okay, then 5.3 says sketch the graph G. Indicate on your graph the coordinates of 2 points on G. Right, so this is a reflection, and understand what a reflection does. A reflection along the line of y is equals to x simply changes your x value to a y value and your y value to your x value. So basically what I'm saying here is that when you have the coordinates here, they are 0 is to 1. It's the y-intercept, but then swapping these coordinates or reflecting these coordinates along the line y is equals to x will make you to have an x-intercept, which will have the coordinates 1 is to 0. And now that we have these coordinates here, they will change to 16 is to 4. So basically it's just taking your x coordinate, making it your y coordinate, and your y coordinate, making it the x coordinate. So that point there will be somewhere here, and then there will be 16 is to 4. Now all you have to do now is to join these 2 points to make your log graph. And note now, the asymptote will be the line of y is equals to, will be the line of x is equals to 0, meant to say. So this will be your asymptote now, contrary to this asymptote here, which was y is equals to 0. So note that. So the asymptote of the exponential graph is y is equals to 0, but the asymptote of the logarithmic graph now will be x is equals to 0. And then just like that, you have your graph you have your graph of g of x. So we can indicate this one as g. Okay. Now, 5.4 is saying use your graph to determine the values of x for which f of x times g of x is greater than 0. Now, in order to successfully answer these questions, you need to know how to interpret these questions here. Now, f of x times g of x is greater than 0. That's just mathematical language. But then how do we change that to a language in which we can understand? So we're going to say this means that we either need where both the graph of f and g are above the x-axis, or where both the graph f and g is below the x-axis. So where both the graph of f and g is above the x-axis, or both the graph of f and g is below the x-axis. So basically that's how we're gonna get a positive there. Remember, greater than 0 means positive. So if f of x is above the x-axis, that means it's positive there. And then also again, g of x above, that means it's positive. Now we know a positive and a positive will give us a positive, right? But then if they're both below the x-axis, then we're going to have a negative and a negative, and that's going to be above the x-axis. But we know one thing for sure, that this graph here for f will never go below the x-axis because of this asymptote here. So remember, the graph cannot go below the asymptote. So that means we won't have a condition whereby we have these two graphs being negative. So that means the only option we'll go for is where both these graphs are above the x-axis, meaning where both these graphs are positive. Now looking at this part here, so we're just going to break this one into two segments, and then I just want to show you this. Now if I can just draw a vertical line over here, draw a vertical line over here like that, we can see that at this part here, the graph of f is above the x-axis, but what is happening to the graph of g? We can see that it is below the x-axis. So that means at that part there, the graph of f is positive, but the graph of g is what? Is negative. That means we cannot have the desired solution to that one. Now let's go and look at the other part here. So let me highlight here. So let's look at this part here. Now, nice. Look at what is happening here. We can see that the graph of g is above the x-axis, and also the graph of f is above the x-axis. So now we can conclude that starting from this point here, from point 1, x coordinate 1, all the way to those x values up until infinity, we will always observe that the graph of g and f will be both above the x-axis. So offering a solution to that, that means now we're going to write our value as 5.4.1. That's when x is greater than 1. Right. Now, they are saying where is g of x less than or equal to -1. So this one is straightforward. Where is the graph of g either equal to -1 or less than -1? Now, considering that, we can see that it will be a point somewhere here. But then we can see that from the graph, there's no way of telling that. So if there's no way of telling that, you can just use the equation. Remember, you have already found the equation of g from 5.2, which is what you have here. You can simply just take the graph of g and equate it to, what's the sign there? Less than. So, and then we say less than or equal to -1. Then we try to calculate the value of x by leaving the x here and then taking the base 2 and then raising that -1 as an exponent. Now x is less than or equal to 1 over 2. Now we do understand that the point in here needs to be 1 over 2. So that's the value there. So your value is either x less than or equal to 1 over 2. That's how you were supposed to tackle that question. Now let's go to 5.5, which is for 4 marks. Okay, now they say if h of x is equals to f negative x like that. Now we need to first understand what is the meaning of this. Now you need to demystify the mathematical language. This is h of x is equals to f negative x. This means that graph of h is obtained by reflecting f on the y-axis, right? So whenever you see a negative x here, just know that the graph h is being obtained by reflecting f on the y-axis. But if you see this, let's say you see this, what's the interpretation of this? You say the graph of h is obtained by reflecting f along the x-axis. So note that a reflection along the x-axis, the negative, you always have it before f of x. But a reflection along the y-axis, you have the negative here inside x, right? So always note that. So what are we going to do now? Let's tackle that one. Now that we understand that this is h of x, now that means our h of x, remember f of x was what? 2 to the exponent of x. Now if h of x is a reflection of f of x in the y-axis, that means now h of x is what? 2 to the exponent of negative x. As you can see here, they've indicated that we should make our x negative. Now remember, the question is calculate the value of x for which of f of x minus h of x is equals to 15 over 4. Now look at this. We have our f of x minus h of x is equals to 15 over 4. Now what is our f of x? That's 2 to the exponent of x. And then what is our h of x? That's now 2 to the exponent of negative x is equals to 15 over 4. Now this will be 2 to the exponent of x minus 1 over 2 to the exponent of x. We've applied a rule there of exponents. And then now, since we are saying that this one and this one are the same, we can then use the k method and say let 2 to the exponent of x be equals to k. So that means our 2 to the exponent of x, we're going to replace it by k. Just like that. And then now we do understand this can be written as k over 1. So if we apply our karate method, that's k times k, which is k squared. And then 1 times 1, that's 1 times negative 1, that's negative 1. And then 1 times k, that's k. So if you are interested on how I did that, the karate method, that's this multiplied by that, that multiplied by that. And then for the denominator, I multiply the two denominators. Okay, then is equals to 15 over 4. Now I can cross multiply this. So k cross multiplied with that one, and then the 4 cross multiplied with that one. Okay, so this will be 4k squared minus 4, and then is equals to 15k. Now bring over the 15k to this side. That's 4k squared minus 15k minus 4, and then equal to 0. Now let's continue here. We have, so if we factorize this, that's gonna end up as 4k, and then let's have minus plus 1, and then k minus 4. So yes, I believe that's going to give us this. And then now my k is either equals to -1/4 or k is equals to 4. But then remember, but our k is equals to 2 to the exponent of x. Remember, we were not solving k, we were just manipulating. We are still trying to solve for x. Then this is 2 to the exponent of x is equals to -1/4. Now we know there is no exponential number there that can give us a negative value. So this, we have to say not applicable. So any number, any integer value, any real number that you will substitute into x there will not give you a negative value. Now my k, 2 to the exponent of x, and then is equals to what? 4. But then now I can write the 4 here as 2 to the exponent of 2, right? So from here I came there, and then the bases are the same. That means I can equate the exponents. Now my x is equals to 2. And that's how you were supposed to solve that question. So you might say that they were a bit unfair when it comes to the marks. There are only 4 marks for all this effort here. But then we know it is what it is. You need to have written that. Okay, so now we have came to the end of the lesson. Please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. And if you are watching this from Facebook, please like the page, follow, and also share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.